Hello everyone, I Dheeraj Singh Khangarot welcome all of you in my YouTube channel School Academy. Today we are going to start our new journey of RBSE English medium courses. We are going to start from 10th class science subject with chapter number 10, which is electric current. Total questions of 5 marks are asked from this chapter. So focus on the screen with me and study. There are total 12 topics in this chapter. We will study one by one. First one is electric current. Second one is potential and potential difference, electric equipments, Ohm's law, resistance and resistivity, combination of resistances, thermal effect of current, magnetic effect of current, direction of magnetic field and field lines, electromagnetic induction, electric current generator, and after all these 12 topics we will study numericals of this chapter in the end. So first of all we start with electric current. What is electric current? We can define the electric current as rate of flow of charge, rate of change of charge, many ways. Rate of flow of charge is called electric current. That's it. Rate of flow of charge means amount of charge which is flowing through a particular point in a conductor or in a wire in a given particular time. Suppose there are 5 coulomb charge is passing through a particular point in a wire in 5 seconds. Then we can calculate the electric current easily. So according to the definition, we can derive the formula of electric current. This is electric current can be defined as rate of flow of charge. It means electric current is charge upon time. If the charge is considered as Q, time is represented as T, and the electric current is represented as capital I, then we can derive I is equal to Q upon T, which is the very most important formula of this chapter. There may be the numericals can be asked from this formula. There are some one-liner questions also, like it can be asked that what is the unit of current, so what is the unit of charge. Alright, so what is the unit of current? The current is measured in ampere, so we can say that the ampere is the unit of current. And what is the unit of charge? The unit of charge is coulomb. Alright. So according to this, what can be the definition of 1 ampere current? We can define 1 ampere current is 1 coulomb charge upon 1 second. So the current will be 1 ampere. If the charge particles or the amount of charge is given to you in the questions, then you can easily calculate by this formula. But if the charge particle or the amount of charge is not given to you in the question, then how will you calculate the current? So first of all, we have to calculate the amount of charge. Here we will see how we can calculate the amount of charge. If n electrons means number of electrons. There may be n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and many more, anything. If n electrons are passing through a point in a conductor, if n electrons are passing through a point in a conductor, then there is a charge, always a charge on each electron, and we all know that what is the charge on each electron? 1.6 into 10 to power minus 19. There is a correction here. Minus 19 is in the power of 10. Alright. So this is the standard formula of charge of each electron. Alright. So if the total number of electrons are given to us n, alright, and the charge on each electron is given to us, which is E, then we can calculate the total amount of charge which is equal to Ne. And we all know that I is equal to charge upon time. It means I is equal to Q upon T. So the value of Q is put in this formula, then we will get I is equal to Ne upon T. Alright. Next. Now we will discuss our second topic, which is potential and potential difference. Practically, there is not too much difference between potential and potential difference, but theoretically there is a difference. Actually, both are like voltage in our circuit, but if we talk about the definition, then there is a minor change. What is electric potential? Electric potential. We can define the electric potential as the work done. Focus on the screen. We can define the electric potential as the work done in bringing a unit positive charge. A unit positive charge from infinite to a particular point, which is A. We are bringing a unit positive charge from infinite to a particular point in an electric field. So this work done is called electric potential. Suppose we are bringing a unit positive charge from infinite to a point A, then we can define the voltage across point A is VA, the voltage at infinite is V infinite is equal to work done W upon Q. So we all know that the voltage at infinite is equal to 0. So we will put the value of voltage infinite in this formula, then we will get VA minus 0 is equal to W upon Q, and the final formula becomes VA is equal to W upon Q. Alright. What is electric potential? When we are bringing a unit positive charge from infinite to a particular point. That's it. And what is potential difference? The work done in bringing a unit positive charge from one point to another point. The work done in bringing a unit positive charge from one point to another, not from infinite. If we are carrying a unit positive charge from infinite to a point, then we can say the work done is equal to electric potential. But if we are talking about two particular points, then we will say it is a potential difference. If a unit charge Q is brought from point A to B, then the similar formula will be derived: VA minus VB is equal to W upon Q. Now we will discuss various symbols of the electrical components which will be used in the circuits in this chapter. So focus on the screen. This symbol is of electric cell or battery. We can write this way. The long side pole will be always of positive side, and the small pole will be of the negative side. So this is the symbol of battery. It means it will provide the supply in the circuit. If we talk about switch or key, then it will be represented as this. If there is nothing in the bracket, then we will say that the switch is off. Switch is off means the current flowing in the circuit will be like this. It will stay here, not will pass this direction. Alright. But if there is a dot in the switch, then we can say that the switch is on. Then the current flowing in the circuit will be passed through the circuit because the switch is on. Alright. Our next symbol is of variable resistance. First of all, we should know the symbol of resistance. Symbol of resistance is like this. We will discuss in topic number 5. Our resistance is represented as R with this symbol, but this resistance is like a constant resistance like 5 ohm, 10 ohm, which is fixed in a particular circuit. But there are many kind of experiments where we have to change the value of resistance at different interval in a particular experiment. So we have to increase the value of resistance and we have to decrease the value of resistance sometimes. So we use a variable resistance or rheostat. So the value of rheostat is, the symbol of rheostat is like this, and it is represented as RH. Alright. We can also represent the rheostat as like this. Alright. This is also the symbol of variable resistance or rheostat. The symbol of voltmeter is simple. We can draw it by simply making a V, positive side and negative side. And remember, always remember, the voltmeter is connected in parallel to the circuit. Alright. Symbol of ammeter is like this. Simply A. Positive side and negative side. And remember, the ammeter is always connected in series with the circuit. And finally, the symbol of electric bulb is like this. These are the symbols in your syllabus, in your standard RBSE book. So we move to the next topic, which is Ohm's law. First of all, if there is a condition of Ohm's law, and the condition is this: when physical states of the conductor like temperature, pressure, length, area should be constant. If the temperature, pressure, length, area of the conductor are not constant, then the Ohm's law will not be applicable to that conductor. So first of all, we have to make sure that the physical states like temperature, pressure, length, area, etc. should be the constant. It means while doing any kind of experiment, the value of these physical states should not be changed. Now we move to this law. Ohm's law. The potential difference, I told you when we study about the potential difference, it's like a voltage. The potential difference between the terminals of a conductor. For example, this is a conductor it means or a wire. There are two terminals of this conductor. The potential difference between these two terminals of a conductor is proportional to the current flowing through the conductor. This is the law. It means how much voltage will be developed across these two terminals of this wire. It will totally be dependent on the current flowing throughout the wire. That's it. If the current flowing through this wire is low, then the voltage produced across the terminal will be low. If the current flowing through this wire is high, then the voltage developed across these two terminals will be high. So we can say that the voltage is directly proportional to the value of current I. In science, we represent the proportional like this symbol. Alright, and we remove the proportional symbol, then we know that there is always a constant. And what is the constant here? Here the constant comes is value of R. And what is R? This R is the resistance of conductor. This R is the resistance of conductor. And this is the most important formula of this chapter. V is equal to Ri or V is equal to IR. This formula will be used at many occasions in this chapter, and you can't do any kind of numericals without using this formula. So always remember this formula. Now the value of R derived from above formula is V upon I. And what is R? I told you R is the resistance of conductor. We will study the resistance in topic number 5. Alright. And what is the unit of resistance? The unit of resistance is ohm. Now we will discuss the definition of 1 ohm. Alright. 1 ohm, it means resistance. And we know that what is resistance? Voltage upon current. What will be, when will be the resistance 1 ohm? It means the voltage should be 1 volt and the current should be 1 ampere. Then the resistance will be automatically 1 ohm. Now we will study the experimental verification of Ohm's law. This is also the very important question of this chapter. The questions may be asked as like state and explain Ohm's law with its experimental verification. This question may be of 2 or 3 marks. So focus on the screen. First of all, we know that what is Ohm's law? The potential difference at two terminals in a conductor is directly proportional to the current flowing through it. Alright, but the physical state like temperature, pressure, length, area, etc. remain constant. This is the Ohm's law. V is equal to IR. Now we move to the experimental verification of Ohm's law. So in this diagram we have to focus that and we have to write the language also in the examination, that there is a battery, a switch K, a rheostat RH, a resistance R, an ammeter and a voltmeter. We have studied about all these symbols in topic number 3. Now we have to write the language like this. Let we have a circuit, a battery B, a switch K, a rheostat RH, a resistance R is connected in a circuit. The ammeter is connected. The ammeter is connected in the series Alright, the ammeter is connected in the series of in the circuit, and the voltmeter is connected in the parallel of the resistance. If we on the switch, it means there is a dot in the switch, then the current I started flowing through the circuit. Then we measure the value of current by using ammeter. Always remember, ammeter is used to measure the value of current, and voltmeter is used to measure the value of voltage. So we will note down the value of current by using ammeter, and we will note down the value of voltage by using voltmeter at different values of resistance by using a rheostat. Then we will receive, there is a graph of a straight line. If we will decrease the value of current, then the value of voltage will also be low. If we will increase the value of current, then the value of voltage will also be increased. So we will draw the graph between the measured voltage and the current as a straight line, which represents that the potential difference received in a circuit is directly proportional to the current flowing in the circuit. Now all the remaining topics we will study in our next lecture. If you have any kind of doubts, you can write us in the comment section or mail us at schoolacademy up to 12@gmail.com. So if you like the video, then press the like button and comment, share and subscribe. Thank you.